Think about it. Every single day we tap, we swipe, we pinch, we live our lives through these amazing seamless sheets of glass. But have you ever actually stopped and wondered what is going on under the surface? Well, let's pull back the curtain and find out.
I mean, it feels like magic, right? It's instantaneous. How does it know the difference between a quick tap and a long swipe? Or how does it tell you're using one finger instead of two? Is it heat? Maybe pressure? The real answer is actually way cooler.
So the secret behind your phone's screen isn't magic, but it is all about electricity. It's a technology that has totally changed the game for how we interact with pretty much everything, and it's called capacitive sensing.
Okay, so what on earth does that mean? Well, to put it simply, your phone screen is always maintaining this perfectly stable, invisible electric field. The system's only job is to watch that field and notice any changes. Now, the key word in all of this is conductive. Because, and you might not know this, you are actually part of the circuit.
Yep, that's right. You are a walking, talking electrical conductor. The screen has a material on it that holds a tiny electrical charge. When your finger gets close, your body's natural ability to conduct electricity actually pulls some of that charge towards it. This creates a little dip in the screen's electric field that the phone can measure. It's kind of like a perfectly still pond. Your touch creates a tiny, measurable ripple. The screen doesn't feel your touch, it senses your electrical effect.
Okay, so that explains how the screen knows it's been touched. But the really important question is, how does it know where? A single ripple isn't enough. The real genius here is an invisible grid made of conductive material laid out in a pattern of rows and columns just under the glass. That grid is everything. And you know, this grid is exactly what allowed for one of the biggest leaps forward in tech history, going from a screen that could only see one touch at a time to one that could see many. This was the multi-touch revolution.
So this grid system is where we see the huge difference between old tech and what's in your pocket right now. Early screens used something called self-capacitance. When you touched it, the screen knew that one row and one column were affected, but it couldn't be sure which exact intersection was the real one. So if you used two fingers, it would see 4 possible points and get totally confused, creating these weird ghost touches. The breakthrough was mutual capacitance. Instead of just looking at whole rows and columns, modern screens have a tiny little sensor at every single intersection of that grid. It can measure the electrical change at each point all by itself. That is the secret sauce that gave us pinch to zoom and all the other gestures we use every day.
So the key here is being able to track lots of points at once and with precision. As the source material puts it, it's not just about your fingers, it can accurately track palms or even multiple styluses all at the same time. That's a massive, massive upgrade. And the impact of this change was, well, huge and immediate. Before 2007, you might have used a clunky single-touch screen on an ATM or a public kiosk. But then the iPhone came out, and it put this powerful mutual capacitance technology into everyone's hands. Almost overnight, it became the gold standard for every single smartphone and tablet.
Now, understanding how this all works also explains some of the weird little quirks about our phones, right? It explains the rules of the magic trick, why some things work on the screen and other things just don't.
This really drives home the difference between our screens and the older tech. Those old resistive screens worked on physical pressure. You had to actually push 2 layers of plastic together to make a connection, but our modern capacitive screens are just looking for that electrical change. It's why they can be made of super durable glass and can handle multi-touch, but it's also why they're a little picky about what touches them.
Which brings us to a super common frustration. It's freezing cold outside, you're wearing gloves, your phone rings, you try to answer it, and nothing. It's infuriating. So why can't the screen see your touch through a glove?
Well, the answer goes right back to that one key principle. Your screen is looking for something conductive. The fabric of your gloves or the plastic of a regular pen are what we call insulators. They completely block that electrical connection. Your finger's electrical ripple just can't get through to the grid. And on a related note, this is also why water droplets or even a sweaty fingerprint can sometimes trigger phantom touches, because they can conduct electricity and mess with the feel.
And that's exactly why you need a special stylus like this. It isn't just a fancy stick of plastic. It has a soft, conductive tip that's specifically engineered to mimic your finger and complete that electrical circuit. That's what allows the grid to see it. But this whole story doesn't just end with detecting touches. The incredible precision of that invisible grid is opening up a whole new world of possibilities. It's turning our screens from simple buttons into really sophisticated sensors.
Now, this is where things get really futuristic. because the system is measuring the disturbance at every single intersection on the grid. It doesn't just see a single point. It's actually generating a low-resolution 2D image of whatever is touching it. Your screen can literally see the shape of your finger or your palm.
And this new ability is leading to some amazing applications. People are developing biometric ID that can authenticate you by the unique shape of your handprint or even your ear print when you hold the phone to your face. It can figure out the 3D angle of your finger, and it can even tell the difference between you pressing with your fingertip on purpose and accidentally resting your palm on the screen.
So, the next time you use your phone, remember you're not just touching a piece of glass. You're interacting with an invisible, intelligent grid that is constantly sensing you. It started by tracking one finger, then two, and now it's learning to see shapes and even identities. Which leaves us with a final, fascinating thought. If your screen can see your handprint today, what else will it be able to see tomorrow?